So chapter 15 is about equilibrium and concentration and pressure change questions and calculations. So they're going to give you some true and false questions. You're going to say if it's true or false. And there are some examples of them. And then here they're going to ask you a question about potential to change the equilibrium in a reaction involving gases. And then they're going to ask you which of these are correct, or if they all apply. And yes, they all apply. These are all correct. And then they're going to ask you a small amount of product is removed from a system at equilibrium, which of the following will change? So these two would change in an equilibrium, the amount of reactants and the value of Q. So the reaction quotient calculation is the reaction quotient calculation, in which we had to find the reaction quotient for the reverse reaction shown below. So they would give you this, and now you would have to find what is the reaction quotient. So to find that, I made note of how to do it. So you would do the reaction quotient is found by dividing the product of the concentration of the products by the product of the concentration of the reactants, where each concentration is raised to the power of the coefficient of the substance in the balanced chemical equation. However, because P4 and P4O10 are solid, the only species we should include in the reactants expression is the gas, O2. The reaction quotient for the reaction is thus QC equals 1, O2, 5. So this would be the correct answer of this reaction. They would give you this, and now you would find the quotient. The equilibrium concentration calculation. So they would give you these numbers. Under certain conditions, the equilibrium constant for the reaction below is Kc equals 0.25. If the reaction begins with a concentration of 0.0638 moles for each of I2 and I negative and a concentration of 0.0 moles for I3, what is the equilibrium concentration of I negative? So they would give you this, and now you would have to find the answer. To find the answer, you would have to create an ice chart, like this one, in which you plug in those numbers inside the ice chart. The ice chart means initial concentration, change, equilibrium concentration. So you would put the 0, because we don't have I3. You would put I2, I negative, plus X, negative X, negative X, X, 0.0638, negative X, and 0.0638 negative X. And then you would have to know this expression, which is Kc equals I2, I negative 3. Plugging these numbers in, you replace each term with appropriate numbers given. So you would put 0.25 equals 0.0638 negative x2 over x. I got these numbers in the question. We see the question, and they give us those numbers. Kc 0.25, 0.0638 moles, and 0.0 moles. And if you look at the expression, you have to plug those numbers in. After you do that, you would rewrite it. After you calculate this, 0.0 equals x2, second power, negative 0.377 plus 4.07044 times 10 to the third power. We use this expression. When we use that expression, we plug those numbers in. After we calculated this, we plug those numbers in to this. When we do the square root over 2, we would get this number. And so then we would get x, 0.011, and x equals 0.367. This means the solution of x equals 0.367 is extraneous because it results in a negative concentration. This is extraneous because it it involves a negative concentration of I2 and I1. Therefore, the value of X is this, 0.011. So the equilibrium concentration of I negative is, we would subtract 0.063, subtracted by 0.011, and we would get 0.053 moles. And this is the correct answer. And remember to always read the question, what is asking you. So let's go back on the question. So it says, what is the equilibrium concentration of I negative? So it's asking for I negative. We go back to the question. And yes, we calculated I negative. And that would be correct. So now the next question would be, solve for the equilibrium. So they would give you this, A plus B and C. The equilibrium concentration are A equals 0.50 moles and B equals 0.75 moles, and Kc equals 4.0. What is the equilibrium concentration of C? So we have to know this by memory to calculate this problem. So we would make note of what is saying on the question. We have A equals 0.50, we have here A, and then we have B 0.75 right here, and then Kc, we would note this down to the side. And then we would substitute this inside the equation. So 4.0, which is Kc right here, equals C. We want to calculate C, so we don't know C. We don't have it here in the note. So we would put 0.5. We have 0.5, which is A. And then the B, which is 0.75. We would calculate this. We would multiply everything, and our solution would be 1.5 moles. And this is the correct answer.